Welcome, friends. Now we have completed transmission line parameters and performance of the transmission line. Now, in this lecture, we shall start a new chapter that is corona. It is a natural electrical phenomena which is very evident to occur in different times. So we shall shortly see what is corona, what is the cause of forming corona, what are the different mathematical aspects of corona and advantage and disadvantage of the corona, and at the last we will solve some problems on corona. So let us start our new topic or new chapter, corona. Now, first of all, it is an electrical phenomena, so it has nothing to do with coronavirus. Okay, coronavirus has started from 2020 onwards. So this corona of electrical engineering has nothing to do with the corona or COVID virus. So it is a natural phenomenon in electrical engineering, as I told you. Mostly it happens in adverse or rough weather conditions like storm and rainy seasons. However, it can happen in normal conditions also. Now, this is inevitable event. This is an inevitable event. It will surely occur at one point of time, and it causes harm to power system in many respects, in terms of power loss, in terms of corrosion, erosion, etc., etc. So it causes harm. Now, when corona happens, what is the definition of corona? Suppose we have a two electrode like this, separated by an gap distance S or D. If potential difference is existing between these two electrodes is V, now if you start increasing this potential difference, at one point of time it will come when these two plates cannot withstand that potential difference, because it exceeds a threshold. Okay, it exceeds a threshold. So if we have a two electrodes like this by a gap separation of distance D, if there exists a potential difference between V between the two electrodes, and if we keep increasing the potential difference between the two electrodes, at one point of time a threshold will be exceeded. So for that, those two electrodes cannot withstand that exceeded potential difference. So at that time, what will happen? An electrical spark will be observed, accompanied by a hissing noise, and of course ozone gas formation. These three will happen. One we will see as an electrical spark, another one we will hear some hissing noise, and chemically an ozone gas will be formed. These three will become. So what is corona? So let me quickly figure out the summary of these 2 points. When voltage applied across two plates, when the voltage applied across the plates exceeds a threshold, right? Then what will happen? It will be accompanied by an spark, then an hissing noise will be observed or will be audible, and finally, and with that, a ozone gas will be formed chemically. So this phenomenon is called corona. So as you can understand, it has nothing to do with coronavirus. Now, why this electrical spark happens? Electrical spark happens is formed with excited electrons. So you see this this electrical spark is can be seen from one electrode to another electrode. Basically, they are the flow of electrons. They are the flow of excited electrons. They are the flow of excited electrons. So basically, electrical spark is formed with excited electrons flowing from one plate to another. So there is a difference between flow of electrons and flow of excited electrons. Current is a flow of electrons. However, excited electron is basically the electrons having high amount of energy, possessing high amount of energy, and that can be visible as an electrical spark. Now, in order to form a corona, I will explain this in a detail in a moment. At least one electron will be needed. At least one electron will be needed. So this process starts with at least one electron. Now, where from that electron will come? That electron will come from that electrode surface. Okay. So at least one electron will be needed that will be liberated from electrode surface. And most importantly, corona is a probabilistic phenomenon. It is not a deterministic phenomenon. It is a probabilistic phenomenon. So if you keep increasing the voltage difference, it is not sure that corona will surely occur. Corona may occur, corona may not occur. It depends on some other factors. So it is totally a probabilistic phenomenon. Now, what is the mechanism of corona? Now, let us say we have a conductor. We have a conductor like this. Now, as you can see, as I have already told you that at least one electron will be needed, and that electron will be coming from that electrode surface. Okay. An electron will be needed to form the electric spark, at least one. That is the beginning, starting point. Now, this electron is liberated from this electrode surface. Say from this point, this electron will be needed. You require force. You have to apply force to liberate one electron from the electrode surface. Okay. Now, you require force. That's right. However, I told you that if the potential difference is existing or potential difference between the two places is kept on increasing, then the corona formation will be seen. So as it can be seen from the definition of the corona that if we increase the voltage at some point of time, corona will form. So the immediate question comes: is the voltage is responsible for this electron to be liberated from the electrode surface? I repeat, potential difference if kept on increasing, then at some point of time the threshold will be crossed and one electron will be liberated from that electron surface, and the corona will be seen subsequently. So the immediate question comes: as we are increasing the voltage, is the voltage is responsible to liberate the electron from the electrode surface? The answer is no. Why? So voltage is not responsible at all. The reason is, what is the definition of voltage? Voltage is defined by, if you have a point P here, so you need to bring a 1 coulomb charge. If you need to bring 1 coulomb charge from infinity to that point. So work done to bring this 1 coulomb charge from that point to point P is called your potential. Okay. So voltage is nothing but a work done. Voltage is nothing but, or potential is nothing but work done or energy. So it is evident that voltage is not a force. So you require force, you have to apply force to liberate the potential difference. Sorry, if you have to apply force to liberate electron from the metal surface. So as voltage is nothing but it's a work done or energy, so voltage cannot liberate electron from the metal surface or electrode surface. So what is the answer then? So you know work done into displacement from the classic definition of work done, force into displacement, right? It is the very definition of the work done. So what is then force? Force is equal to work done divided by displacement. So from this equation, it will be clear to you in a moment who is the responsible to liberate electron from the electrode surface. Now you see work done is nothing but voltage. And what is this displacement? Displacement is nothing but the, this is the gap distance. So it is not voltage is responsible to liberate electron from the electrode surface, but it is the voltage gradient. It is the voltage gradient. It should be represented in unit kilovolt per meter. So force which is required to liberate one electron from the electrode surface, who is creating or who is liberating electron from the electron surface? It is not voltage, it is voltage gradient, voltage per displacement. Okay. So now if we have one electron available, then that electron must have some high amount of energy. Okay. Now if an object having a high amount of energy, now this electron will collide with some air particle. Air is a free state or air is in a normal state. So if a particle with a high energy collides with another particle with normal energy, then this air particle will be energized. Okay. So from one electron we were getting two electrons with high energy. So due to one collision from one electron we are getting two electrons. Again, with these two electrons available, these two electrons collides with another two electrons, another two air particles. So if these two air particles, these two newly normal stated air particles is converted to the excited air particles, in this way this cumulative or successive collision occurs, and this entire gap, suppose this is the two electrode, so this entire gap will be filled by this excited electrons. So when this gap is sufficiently filled by this excited electrons, so those electrons at some point of time, those electrons can be seen as an electrical spark visually. So that phenomena is exactly called corona. So corona starts with an electron, at least one electron you will require. That electron will collide with one air molecule or air particle which is in a normal state. So that air molecule will be energized due to this high energy of electron. So from one excited electron we are getting two. Then from 2 we will get 4, from 4 we will get 8. So in this way this entire gap will be filled, or this entire gap will be bridged by those excited electrons. And when the gap is filled by sufficient number of electrons, then those electrons can be seen altogether as a form of spark, right? As a form of spark. That means it's the mechanical energy is converted to the light energy. It is the spark, light energy. It's the spark. Sound energy, which is the hissing noise. And finally, we will have a chemical energy. That is the ozone gas formation. Ozone gas formation. So these three will be accompanied. Okay. So as I told you, let me quickly check the fact one by one points. Now force is essential to liberate one electron from the electrode surface, that I have told already. So voltage is very important, which is an energy. It's not sufficient, therefore voltage cannot free. Okay. So who is responsible? It is the voltage gradient. It is the responsible factor, responsible quantity that causes electrons liberated from the metal body. Now the free electrons with high energy collides with neutral air particle. Consequently, air particle becomes excited with high energy. In this way, with successive collision, the entire gap distance is bridged or filled by the electrons, excited electrons, and thereafter it can be seen as a spark or flashover. Now finally, why the corona is called it's a probabilistic phenomenon? Why it is not deterministic? Because, so I am saying that I am claiming that from one electron we are getting 2 electrons. From 2 electrons we are getting 4 electrons. Then 4 electrons we are getting 8 electrons. From 8 electrons we are getting 16 electrons, and in this way this build up process is going on. Now this is not true. Now you see, from this 1 electron you may not get 2 electron at all. You may not get. Okay, it depends on the amount of energy it is having. Though from 2 electrons you may not get 4 electrons. Again, why? Because it depends on the how much energy those 2 electrons are having. So it is not like that it's always that from 1 electron it is 2, from 2 to it is 4 electrons. It's not always that. It depends on the total amount of energy it is possessing. Okay, so the number is increasing, that's right, but if the gap is not filled by the sufficient number of excited electrons, corona cannot be seen. So even if we increase our voltage, if the gap is not filled by the sufficient number of excited electrons, then corona will not occur. So that is totally, I am claiming that it is a probabilistic phenomena due to this reason. It is totally depend on the availability of the excited electrons. If we have ample amount of excited electron, corona will be seen. If we do not have the ample amount of excited electrons, corona will not be seen in spite of voltage exceeds its threshold. Okay, this is the mechanism of corona. Next, now what is that threshold? So I keep telling you that if it crosses the threshold, what is that threshold then? So the threshold is this. So it is the breakdown, it's called breakdown strength of air is 30 kb peak per centimeter at STP. It's very important. Breakdown strength of air is 30 kb peak per centimeter at STP. This is a very important statement. Why air? Because we have this gap is filled by air. That is why we are considering air. What is the meaning of this statement? Suppose we have a gap distance of 1 centimeter. Now if we apply a potential difference of 30 kb peak, mind it, not RMS, it should be peak value. So if for a 1 centimeter air gap, if we apply 30 kb peak potential difference across that gap, then that gap is most likely to be fired. Fire means it is, corona will be seen. That is the meaning of that. And in above to all, this entire experiment has to be done at STP. What is STP? It is standard temperature and pressure. Standard temperature is 25 degrees Celsius and standard pressure is 76 centimeter mercury pressure. So I repeat, what is the statement of the meaning? 30 kV peak per centimeter. What is the meaning? If we have a gap distance of 1 centimeter, and if we apply a potential difference of 30 kV peak, not RMS, 30 kV peak, then that gap is most likely to be fired. Okay, and that entire experimentation has to be done at STP condition. What is STP? It is standard temperature is 25 degrees Celsius and standard pressure is 76 centimeter mercury pressure. So if we change if we conduct this experiment at different atmospheric condition, then this value will change accordingly. The breakdown strength of air will change accordingly. So it is mentioned that STP stands for, it is 25 degrees Celsius temperature and 76 centimeter mercury pressure. The meaning, so voltage is applied across an air gap of 1 centimeter, the gap is most likely to be break at STP. And now one question comes, why I am using 30 kV peak? Why not 30 kV RMS? It is very important. Now, why it is peak, not RMS? The reason being, I already told you that corona is a totally probabilistic phenomenon. Okay, so the success of that event is totally dependent on the initial available excited electrons. Now, if the input voltage follows a sinusoid curve, so this is peak value. This is the peak value. Now, the probability of available electrons, suppose this peak value is point X and some other point, let us say point Y, any other point other than that peak, that is point Y. So the probability of getting excited electron at peak point is more than any other point. I repeat, probability of having excited electrons at this peak voltage will be more than any other points, because it corresponds to high voltage, highest voltage. So that is why this statement is always said 30 kV peak, because it is a highly most probable voltage at which we can have maximum number of available electrons. So that is why it is mentioned 30 kV peak per centimeter, not RMS value. Now, as I told you, it depends on if this experiment has not been conducted at STP, so this breakdown strength will vary with different ambient conditions. Okay. How? Now, one factor is called air density correction factor. One factor is there, it's called air density correction factor. So this factor will determine how much it will vary. Okay. How much it will vary. So it is given by delta, it is air density correction factor 3.92 B by 273 plus T. P is the pressure, T is the temperature. So breakdown strength of varies depending on this value. And now I give you an example. Suppose a place X Okay, suppose a place X, how it will vary? Suppose any particular place, any random place has pressure is equal to 75.606 centimeter mercury pressure, and temperature is equal to 32 degrees Celsius. Then it is said that what is G0? G0 is the breakdown strength of air. Is breakdown strength of air. It is given 29.15 kV peak per centimeter. It is not given at 30 kV peak, but it's changed. Now how it is changing? Now let me evaluate delta for these two values. So delta will be 3.92 into B. What is B? 75.606 divided by 273 plus T. 273 plus T, that is 32. So if you solve this value will become 0.9717. This delta. Now at STP, my breakdown strength is 30 kV peak per centimeter. So at some other condition, my G0 will be, at some other condition, the new G0 new will be, or G0 modified, that will be this delta times G0. That means it has to be multiplied with this correction factor delta, and you multiply with G0. So it will be nothing but 0.9717 into 30, which is coming out to be 29.15 kV peak per centimeter. So this is how the breakdown strength of air varies with different conditions, weather conditions. Whether it is a cold place or whether it is a hot place, whether it is in a near to the sea or it is a mountain area, it depends. This value will change accordingly. Okay. So with this, I am stopping here. So just to brief recap what I have discussed till now. So we have started corona. We have defined corona. What is corona? Thereafter, what is the cause of corona, formation of corona, how corona is formed. It requires at least one excited electron to start the process, and if the gap is having sufficient number of excited electrons, then that kinetic energy can be seen in terms of three energies. Those kinetic energies is converted into three energies. First is it is sound energy, which is a hissing noise. Secondly, it's a light energy, which is a electrical spark is seen, and lastly it's a chemical energy, which is ozone gas formation. And thereafter we have seen this depending on different weather condition, how the breakdown strength of air changes. At STP it is 30 kV peak per centimeter. It should be mentioned peak value, 30 kV peak, not RMS. However, at different weather condition, that 30 kV peak per centimeter value should be corrected according to the air density correction factor, which is delta, and it should be modified or it should be corrected accordingly. And I have shown you one example of that. So I am ending here. In the next lecture we shall see some more aspects of corona. Thank you.